All right, so we're just simply going to multiply the concentrations by themselves. Easy enough. Okay, KSP is the solubility product. It does involve stoichiometry though. No, this is not that bad. All right, so if it's BaCl2, when this dissociates, you have 2 Cl minuses. What do we do with the coefficients? It becomes an exponent. So this one would be, whoops, that's the worst underline ever. And this is kind of ugly, but it'd just be Cl squared. You with me? Writing the equilibrium expression for KSPs are really simple. Now, there is a tricky part we'll talk through, and like 5 of you will never understand it. All right, so when solving for the concentration of an ion, make sure to account for the subscripts in the formula. Yes? This one, that's just the charge. This is really written poorly. Let me just write it out. So it'll be the concentration of barium plus 2 times Cl minus 1, and that would be squared. That is kind of confusing. Okay, so we do have to make sure we account for that. Now this, let me see what the next slide is. All right, this is where it's going to get tricky. Are there any seniors in here? Never mind, I won't read it, but it just says the seniors never fail to disappoint, because your group chat has about 700 messages in it since the start of lunch, and the admin is annoyed. Okay, I need you, I know I'm the distraction half the time. I need you right now to stick with me, because this gets confusing for a minute. BaCl2 goes to Ba plus 2 plus 2 Cl minus. You with me? Okay. The equilibrium expression, or KSP, would be equal to Ba and 2 Cl minus, or sorry, and Cl minus squared. That was annoying. You'll see why I did that in a minute. Okay. Now I need you to really grasp this next part here. If I already know, like a given amount, let's say I have 0.15 moles of this, and it will dissociate into 0.15 moles of this and 0.3 of this. You with me? Who's with me?
Can't you just say x plus 2x and create an equation for whatever?
Yeah, we're going to go there in a minute, because we want to know the easy equation for all of them, because it is easy. But I have to have kids understand why. All right, so I could put these in at 0.15, and this would be 0.3, right? And this would be squared. Do you understand my substitution so far? Just putting them in. Okay. Okay, this is where the massive problem comes, and the answer is no. I'm right, you're wrong. But trust me, half the class is there. They're like, wait a minute, didn't you already account for the 2? Everyone look at me, because this is what kicks your butt. I have to account that 2 of them come off for every one. And in the expression, I have to account that the coefficient was a 2. You have to do both. You have to do both. And that's where you kind of screw up, because you're like, oh, I did that. I don't need to square it. But we just doubled it. Squaring it's different than doubling it, right? Okay, so this is a little bit tricky. But if I didn't know these, I would just say, this is what we were leading to here. KSP is equal to, why'd I go so big? If I don't know what it is, I say it's X. Okay. Now that would represent the concentration of Ba. I'm just writing a general expression when I don't know it. You with me? And the concentration of Cl minus would be 2x. But 2x also must be squared. So this ends up that the general statement when you have a 1 to 2 dissociation is that KSP is equal to 4x cubed.
Where did you get the four? Yeah, where's the four from?
What happens when you square a 2? Yeah, and I know, like, this is basic math, but for some reason we throw chemistry in and you're like, oh, it doesn't make sense. If we had not said anything about this and I said, what's 2x squared? I would have had 4x squared, right? So that's where this comes from. Now, what is x? X equals the concentration of the mono ion. What's that? Right. So this one, it would be barium because it was only a 1 in the BaCl2. Thank you. All right. Oh no, Preston has some drama. This is scarier than going to the principal's office, in my opinion. All right. Who's with me on how this all worked out? Okay. So if x is equal to that, and let's say x, we did some math that it was like 2.5 times 10 to the negative 3, then we would say the concentration of Ba plus 2 would be equal to 2.5 times 10 to the negative 3. What would the concentration of Cl minus be equal to? You with me? Okay. What if it's just a straight single ion binary compound like NaCl? What would KSP general statement be? It's just equal to x squared. You okay with that? All right. What if these are rare, but what if it was AlCl3? KSP would be equal to x, 3x cubed, close, 27x to the 4th. Now those are really rare, but they're still doable. And I wouldn't I wouldn't try and come up with it. I would memorize it. So if it says the KSP of AlCl3 is equal to, I don't know, 3.6 times 10 to the negative 5, then what's the concentration of Al plus 3 and the concentration of Cl minus? Go ahead.
What happens when the anion charge is more than 1?
This gets tricky and you just look at the ratios.
And that gets to be the math?
Yeah, you would have to, but you're never going to do this where you have 2 different numbers like Al2O3. We're not doing it. It's just a big mess. Honestly, it's going to be squared or 4x cubed 99.9999% of the time. Okay, how would we solve this problem then? We just say that 3.6 times 10 to the negative, what did I make up? 5 is equal to 27x to the 4th. So I divide both by 27. And then I take the 4th root. That'd be ugly, but like we can do that. How do you type that in your calculator? If I raise it to x to the negative number, does that do the same thing? I can't remember. There's a raise it to the negative 4th. Isn't that the same thing? Oh yeah, 1/4. The 1/4, yeah. I remember still to this day, it would have been 1997. Nope, 1998. I took Math 1050 and I took the final and it had a fraction of the exponent. I didn't know what to do. Like the final, it's not even hard. I was like, who knew you could put fractions up there? I have no idea. Well, in the class, I got like a B. You had to get a C to pass the class, and I knew I failed that final, but he never gave it back to us. I swear we all bombed it, and he just shredded them. He's like, I'd have to fail everyone. That's on me. So pass math 1050. All right, looking good out there. We only have a couple blankets in this sector. All right, what did we end up with? Anybody? 0.0339. Do we agree with that? I have no idea. Okay, we have a few. Okay, we won't have to do this very often. This one, I wouldn't stress about that. Okay, here we go. You have to be able to go both directions with KSP. And it's pretty simple. You have to be able to use KSP to solve for the concentration of any of the ions, which we just did. Once you solve for X, though, you got to make sure you keep track of your stoichiometry. Right? All right. And then you have to be able to use the concentrations to find KSP. And that one's easy. Just plug them in. Okay with that? Okay. What's the concentration of Cl minus in a solution of AgCl if the KSP is this? Some people that already figured it out, they're probably done. If you haven't yet, that's fine. Let me go here. So 2.35 times 10 to the negative 8. This is just a straight binary, meaning there's 1 and 1 or just 2 total. So the KSP is equal to Ag times Cl, and they're going to be the same number, right? Or X squared. So I simply just take the square root of the KSP and I'm ready to roll. There are throwers literally right there. Boys, the throws coach is right there. It's Scott Walker. So I'm going to think that he's going to say something like, get the something out of my sector. Oh, and they're moving. Just takes an overweight guy with a beard and you'll move.
Why is that such a overweight guy's beards?
What's that?
Why are they so intimidating?
I don't know, but they are. It's because you know they probably got a gun. Like you look at me, you're like, no, he wouldn't have a concealed carry. You look at Walker, you're like, he probably has 3. All right, that was easy, wasn't it? So, we ready? Well, hey. Oh, what do you need? Yes. Just leave the chat for a minute. What? I have not watched it. What are we up to now? Like 200 messages?
People are upset. That's all I have to say. Also, it's only boys that are upset.
152 messages since launch. They're arguing about the theme, which, why do you kids care about themes anymore? Like, I didn't. Okay, moving on. This is all being recorded. Do this problem. I'm going to do it in white because I can.
You did it amazingly.
Oh boy. We're going to see how this turns out. I don't have faith in this one.
Wait.
We'll see. Nice. So fundamentally, you know one thing. This will equal something.
Aren't you so proud of us? I got a very, very small number too. We got different very small numbers. It feels small. Very small number.
Oh, no.
All you're doing is moving the face.
This was cut from the book. Oh, no. What the? Why? Okay, screw it. Oh,
We got something. KSP equals, oh, oh. Oh. I was right.
that's what I got. All right. How we doing? So if I want KSP, it's equal to 4x cubed, right? And they gave me x. X is the concentration of the thing you have one of. And we got lucky, it gave us that, right? It asked for, or it gave us H. So we substitute the concentration of H in for 4x cubed. It should be a really small number because it has a really, really small KSP. So what did we get? Something times 10 to the negative something.
3.292 times 10 to the negative 31.
Okay, is this very soluble? No, we would really say this is the extremely weak electrolyte. Who?
Yeah, I got 5.2.
Oh, the 4 came because the equilibrium expression is equal to x,
I
2x
figured out 4kx squared and then I multiplied that by x.
squared. Distribute that, you get 4x squared times x.
Yeah, I did.
4x
I
cubed.
did in that order.
I was telling her how to set it up. I don't know the math.
Yeah, I got the same thing.
This one or the other one?
I got this one, but
Okay.
I've gotten both of them.
Okay, order of operations.
You need to do the exponent first.
The exponents are the first order of operation, are they not? I don't remember. I'm not a math guy.
Parentheses.
Okay, I don't remember. Okay, who raise your hands if you're okay with the idea or the concept? Okay,
0.00000000000.
I'll forgive you.
0.0000000. Have I made my point yet?
Yep, it was a small number. Okay, try this one real quick. I feel pressure watching all those people show up and I'm in here.
Oh, boy.
What time are we out of here?
I don't remember.
All right, apparently we get out at 1:10. No? Today, today's a weird day.
No, that's not allowed, actually. You really no, you didn't see anything.
All right. How did this one go? Good. All you have to do is what? Square it. Why? Oh gosh. What is it asking for? The KSP of AgNO3. So it's equal to Ag plus and NO3 minus times each other. So you take this number, you know they're the same because AgNO3 breaks into 1 Ag plus 1 NO3. So they're the same number. So I have 1.3 times 10 to the negative 2 twice. Or I just square the number it gave me. How do we feel about that? Better?
I almost did the whole 27x to the 4.
Yeah, don't do that.
I yelled at me.
Is that because there was
But
this?
there was a 3.
Yeah, don't fall for that crap. It would have to be a
What's
3.
I know. I'm very aware.
I guess that's the answer.
Yes, it was.
1.7.
1.6 or 7, I guess.
Hey, I'm gonna be wrong because I was.
All right. So a saturated solution is prepared. This is from an old AP test. You should pray you get a KSP problem because they are seriously the easiest of all that we do. All right. So it gave you PBI2, it goes to PB plus 2 plus 2KI, or sorry, 2I. Write the expression. This is easy. It's just making sure you remember not to include the solid, right? So PB times I squared. All right. Can we all have done that? Okay. Calculate the molar concentration of I minus in the solution. Everybody look at me. We're going to solve for X. Is X the answer to this question?
No.
No. What is?
2x squared.
2, no. 2X. The only time you square it is in here. All right, but we're not asking what this concentration is squared. We're asking what it is once we solve for the concentration of PB. Once we know PB, which is what X is, I is twice what PB is. So when it's a 1-to-2 ratio, we know our KSP is equal to 4x cubed, right? Do we have the KSP for this? Oh, this is easy. Well, my bad. Sorry, I could do this in my head. That's my fault. It gave it to you. It didn't give you the KSP, the problem. It gave us PB. So all we had to do is double it. That was very sweet of them. They made it way easier. That's on me. Second time in 2 days, I haven't read the whole problem first. Now we find the KSP. So the KSP, we can just plug in that in 4x cubed, or you just fill it in. Either way, I'll do both. So KSP is equal to 4 times 1.3 times 10 to the negative 3 cubed, or it's the same. KSP is equal to 1.3 times 10 to the negative 3 times 2.6 times 10 to the negative 3 squared. Both of those are the same exact expression. All right, looks like we have a couple teams now. 3. Skyview always drops their kids off at the same spot. And then they get into the field way up there and realize there's no way in. So let's go all the way around. It's 10 years, like 20 years. They should know that by now.
So in other words, there's not a lot of competition.
No, they're pretty good. Okay, a saturated solution is prepared by adding PbI2 to distilled water to form 2 liters at that. What are the molar concentrations of Pb plus 2 and I minus in this solution? Justify your answer.
Is it saturated like?
It means it's saturated. Means it's holding as much as it can based on its KSP. Here are your answers. Wait a minute, they're the same.
Okay,
We-
liters throwing me off. Felt like I-
Well, the 2 liters, guess what? If you add twice the water, twice of it dissolves. But the amount that dissolved and the volume increased the same, so the concentration is the same. KSP says as long as we have stuff, the concentration is going to stay the same. If I add more water, more breaks apart, but it's the same ratio. So I could add 100 liters and the concentration stays the same. All right, solid NaI is added to a saturated solution. Assume that the volume does not change. Does the molar concentration of PbI plus 2 in the solution increase, decrease, or remain the same? Justify your answer. We haven't talked about that yet, but we can do it. Well, let's look. This is a Le Chatelier's principle question. What am I adding to this system? Sodium iodide, right? Does that have a common ion?
Yes.
Okay, so I increase the amount of iodine. What does the system do? It moves over here. So does the molar concentration of Pb plus 2 change or increase, decrease, right?
Yeah.
Because we go away from that side. Justify your answer. What? I don't remember.
I'm
Well-
sure you're close. Isn't it like a triangle of the A? No, right out.
There's the try. Okay. According to Le Chatelier's principle, they'll enjoy all the different spellings we do. That'll be their favorite part of the test. According to Le Chatelier's principle, if I add some product, the other product decreases or the reactant increases, something like that. Okay. This is like medium difficulty compared to what we've been doing, right? Let's see. Wow. Oh, this is actually really important. Just, you don't have to write it down, but KSP and solubility aren't the exact same thing. Like it's a ratio of its solubility at equilibrium, but it's not exactly the same thing as solubility. I feel like maybe I should get out there. What do you guys think? No. Okay. Common ion effect. We just applied this. I remember I said I didn't teach it yet, but then I just did it with Le Chatelier's principle. The common ion effect says if I add either one of these ions, the solubility of the overall substance decreases.
We already know it's just a very different name.
Yeah, it's Le Chatelier's principle. We're just now saying this common ion decreases because it shifts the equilibrium towards the solid instead of the ions. You all right with that? I can't believe Jeff hasn't called me yet. Be like, where are you? I will end here in a couple minutes. I think I'll come back, but I think like we're 2 slides away from being done. Because we already did that problem. And we're on this slide, right? Okay. Factors that affect the solubility besides the common ion are the pH. Some things dissolve better in acidic and worse in basic, or vice versa. If a substance has a basic anion, it will be more soluble in acidic solution. So if I have NaF, it goes to Na plus F minus. If I put this substance in an acid now, the H plus grabs the F minus, right? Which means that I'm removing this, which means this shifts towards it. It makes sodium fluoride more soluble. But if this was in a base, it would reverse the process. You know, there's a lot of things I don't like at track meets, and part of them is like the hour before. So I think it's kind of nice just watching all the busybodies out there. The only problem, the only thing he needs me for is to turn on the mic to tell the kids where the bathrooms are. That's like the #1 question we get. Where's the bathrooms? Like, not in this room. Get out. Okay, so far okay? All right, the very last thing of this whole chapter is looking at something and knowing if a precipitate forms. A precipitate, you should recall, is when the plus and the minus, they combine instead of being dissociated, and we end up with an insoluble product at the bottom. You remember that? Good. And it's pretty simple to know. Do we remember what Q is?
Sometimes where the
All right, good. I'm going to say a reaction, but everything else is perfect. It's the conditions at that moment in time. We don't know if it's at equilibrium or not. It's at that specific moment. So it will give you the conditions and you plug it into the expression. And if Q equals KSP, the solution is saturated. It's holding as much as it can. Go ahead.
precipitates, do they have the K?
Yeah, they're just really small. Everything we've done so far is one that will precipitate. Because if it doesn't, we wouldn't do it in the first place. So every time we do a KSP, it's for a weak electrolyte, which are precipitates. Because the strong electrolytes, it's basically infinite again. All right. If Q is less than KSP, more solid will dissolve, which means there will not be a precipitate. If Q is greater than KSP, the salt will precipitate until they equal each other.